Hi friends, welcome to Easy to Learn channel. In this video I am going to explain about Fourier series. The topic is Fourier series representation of a continuous time periodic signals. The Fourier series is mainly applicable for periodic type of signals, and these are not applicable for a periodic type of signals. In my previous videos we have seen the periodic and aperiodic type of signals. In this, the first topic is a trigonometric Fourier series. So number of problems are there on trigonometric Fourier series. So this trigonometric, how to find out the trigonometric Fourier series. So if you take a complete set of functions which consisting of a set of cos signals and sine signals. So I am taking here the cos signal as cos n omega naught t and sine signal as n omega naught t. And here the n values are starting from 0 to 0, 1 and so on. So this forms a complete orthogonal set. That is nothing but what? It is a combination of cos terms and sine terms. Both the terms which forms a complete orthogonal set. Now this set of orthogonal functions are given as, so you have to substitute n value as 1, 0, 1 and so 1, 2 and so on. Now after substituting here cos 0 value, cos 0, cos 1, cos 2 and so on up to cos n omega naught t. So in the same way sine omega naught t, sine 2 omega naught t and sine n omega naught t. Right? So these are the set of complete set of orthogonal signals. Now if you take any function in Fourier series, if you can be represented in terms of these functions over an interval, so that is 0 to t, you have to represent 0 to t, or t0 to t0 plus t, or t0 to t0 plus 2 pi by omega naught. So if you have to take any of these intervals in Fourier series. In exam point of view, if they are not given the limits, means you have to take any one of the limits. Okay. Now f of t is equal to a naught plus a1 cos omega naught t plus and so on an cos n omega naught t and so on, b1 sin omega naught t, b2 sin 2 omega naught t and so on, bn sin 2 omega naught t. Now these terms, cos terms, are represented with a variable an, right? It can be represented with an, and sine terms are represented with these are the component functions which are represented with b. So based on this, a naught plus summation n is equal to 1 to infinity an cos n omega naught t plus bn sin n omega naught t. Here the t limits are what? T naught to t naught plus t. How to get 2 pi by omega naught? Here omega naught is equal to 2 pi f. That is nothing but 2 pi by t. Right? T is equal to what? 2 pi by omega naught. So in place of t, you have to represent 2 pi by omega naught. Now, so here I am taking t limits are t naught to t naught plus t. So from equation 1, the trigonometric Fourier series, this is the equation of trigonometric Fourier series. If you find out the trigonometric Fourier series, means you have to find out a naught value, an value and bn value. After getting all these values, you have to substitute in this equation. We are getting the trigonometric Fourier series. Now how to get a naught, an and bn values? So these a naught, a1 and so on an, b1, b2 and so on bn are the components of f of t along the mutually orthogonal set. So these are the components of a is the components of cos term and b is the component value of sine terms, and this orthogonal set which is given by, and this component value is what? C12 is equal to, we have already know this formula. In if you see in previous videos, we have to solve the component value, that is integration t1 to t2 f1 of t f2 of t into dt divided by f2 square of t into dt. Similarly, so we have to find in the trigonometric series, we have to find a naught value, an value and bn value, right? First I'm taking an value. So how to find out that an value? So here the integration. So this an value which consists of what terms? Cos terms, right? And bn value consists of sine terms. Now I am taking one of the signal. That means we don't know first signal f1 of t. Let us take f2 of t signal as a cos signal, right? So f of t cos n omega naught t into dt integration cos square n omega naught t into dt. So first we have to find out an value, right? So in this equation we have to find this value. What is this value? So for that you have to take that equation integral t naught to t naught plus t cos n omega naught t into dt is equal to integral t naught to t naught plus t cos, what is cos square n omega naught t value? That is 1 plus cos 2n omega naught t divided by 2 into dt. So keep this 1 by 2 outside. Integral limits t naught to t naught plus t 1 plus cos 2n omega naught t into dt. Now integrate. So the integration of 1 is what? T. And the integration of cos 2n omega naught t is what? Minus sine 2n omega naught t divided by 2n omega naught t with limits t naught to t naught plus t. Right? Now substitute the upper limit and lower limit. 1 by 2, 1 by 2. So here in place of t, first substitute upper limit, that is t naught plus t minus t naught plus. Now again sine 2n omega naught t, in place of t substitute t naught plus t divided by 2n omega naught t minus sine 2n omega naught, lower limit. Okay. After that, so here these two are cancelled. We are getting t plus sine of 2n omega naught t naught. So you have to multiply this term into t naught plus this term into t. Now what is t value? 2 pi by omega naught. So I am substituting here 2 pi by omega naught getting cancelled. Minus sine 2n omega naught t divided by 2n omega naught t. Now 1 by 2 t plus, so this 1 by 2n omega naught, here also 1 by 2n omega naught. These two are common, right? You have to common that one. 1 by 2n omega naught t, 2n omega n, 2n omega naught sine 2n omega naught t naught plus 2n into 2 pi. What is that one? 4n pi minus sine 2n omega naught t naught. Now t plus 1 by 2n omega naught. So sine of 4 pi plus theta. So you can get sine theta, right? So that is sine of 2n omega naught t minus sine 2n omega naught t. So these two are cancelled. We are getting 0, right? So that is t plus this value into 0. This value is 0, right? You have to multiply these two. We are getting 0. T plus 0 is equal to what? T by 2. Now what is an value? An value is what? This one. We have find this value cos square n omega naught t. What is that value? T by 2. Now denominator part we are getting t by 2. If you send numerator side, means that is 2 by t integral t naught to t naught plus t f of t cos n omega naught t into dt. So this is the an value. So in exam point of view or in trigonometric Fourier series problems, they will give f of t value. You have to substitute f of t value here and you have to find out an value. So in the same way we have to find a naught value. So we already know an, right? So that is, this is the an equation, right? So if you find a naught value, you have to substitute in place of n 0. That is an in place of n you have to substitute 0, right? That is cos n omega naught t dt divided by cos square n omega naught t into dt. Now in this cos of 0 in place of n I am substituting 0. Here is also 0. So that is cos 0 value is 1. Integral t naught to t naught plus t f of t into dt divided by integration of cos 0 value is 1 into dt. So if you integrate 1, we can get t. So if you substitute upper limit and lower limit, t naught plus t minus t naught. So these two are getting cancelled. We can get 1 by t integration t naught to t naught plus t f of t into dt. So this is the a naught value. Okay. So now find out for bn. How to find out bn? So what is the which values are there in bn? That is sine values, right? So the same equation you have to take bn as f of t sine n omega naught t dt divided by sine square n omega naught t into dt. Now so integration t naught to t naught plus t, this is the denominator part. So first you have to find out the denominator part, that is sine square n omega naught t. So the formula for integration of sine square n omega naught t, if you find, so you have to substitute the sine square n omega naught t formula, that is 1 minus sine 2n omega naught t divided by 2 into dt. Now 1 by 2 integration t naught to t naught plus t 1 minus sine 2n omega naught t into dt. Now 1 by 2. Now integrate this 1. 1 value is t and integration of sine value is what? Cos 2n omega naught t divided by 2n omega naught t with limits t naught to t naught plus t. So again the same procedure which we followed in finding the cos term, cos n omega naught t, the same procedure here also, that is 1 by 2 t naught plus substitute the upper limit minus lower limit plus here also substitute upper limit minus lower limit. Now again multiply these two. Okay, so you are getting 2n omega naught t plus 2n omega naught. The t value you have to write it as 2 pi by omega naught, right? So here omega naught getting cancelled, you are getting 4n pi. So this value is nothing but cos 4 pi plus theta, we are getting cos theta. So here is also cos theta. So this value is what? 0. So these two are cancelled, this value is 0. 0 multiplied with this term is also 0, right? So you are getting again t by 2. So what is bn value? Bn value is equal to this equation. What is the denominator part? We are getting t by 2. That is nothing but bn is equal to 2 by t integration with limits t naught to t naught plus t f of t sine n omega naught t into dt. Now if you find out the trigonometric Fourier series, so this is the trigonometric Fourier series equation. So if you find out this Fourier series means we have to find a naught value, an value and bn value. Based on these three values, you have to substitute here. We are getting the complete trigonometric Fourier series. Thank you.